Hi everyone, today we'll be discussing about Turbocharge your MySQL engine on Azure to make it fast, resilient and scalable. And I am Amol Bhatnagar and I work on Azure open source databases and Microsoft. Right now, my area of focus is Azure database for MySQL and Azure database of MariaDB. And prior to joining to Microsoft, I have worked as a software designer at Hewlett Packard Enterprise, and I have also done my masters at Carnegie Mellon University. So let's go deep down in agenda of today's session. So today, basically, in this presentation, we'll be discussing about what's new with Azure Database for MySQL, and then after that, we will be deep down on what matters for getting maximum performance. So in this section, we'll be discussing about what basically you can achieve and do on the Azure MySQL side to get the maximum performance. The next session we will be discussing about how you can right size your Azure MySQL based on your workload to get the maximum performance. The fourth agenda item which we'll be looking around is basically the demos for performance improvement. Here I will be talking about that one of the rewrite only workload in Sysbench, and I will be running through the performance and showing you the performance across AWS RDS instance and Azure MySQL and MySQL community version installed on Azure on the on-prem. So let's go deep dive into the first section of our agenda. So in the first agenda, I want to talk about the available MySQL deployment option. And as of now, if you want to deploy your application with Azure MySQL, you have two choices for the MySQL deployment option. The first choice is basically is the single server option. The single server is enterprise ready, fully managed community OS engine, which we have, and now we are launching a new flexible server preview where you can get the maximum control with a simplified developer experience. So in this offering, we have improved many things which I will be discussing about in the next slides, and all those features give maximum control with a simplified developer experience. So let's go next in another slide to discuss more about the features which give maximum control and a simplified developer experience on flexible server. So moving into the next section, in flexible server for Azure database for MySQL, you can get the maximum control for your database. So basically what I mean when you get a maximum control for your database, so we have released some of the features on flexible server. One of the feature which include is network isolation with VNet integration. So basically in this network isolation with VNet integration, during the provisioning experience only, when you are provisioning your Azure MySQL, you will have a complete freedom and choice to choose what matters most for your networking choice. If you are a secure enterprise and if you want to deploy your Azure MySQL in a secure environment, you can choose the network isolation with VNet integration, and that will deploy your Azure MySQL in a complete secure environment, and you can only use the Azure MySQL through the same same VNet where your Azure MySQL flexible server is deployed. So this is one of the latest feature, and to call it out again, you can choose this network choice during the create experience. The another important feature which gives you maximum control on Azure MySQL is basically the more server parameter and fine grained tuning. So we have provided and make more modifiable server parameter from the single server, where you have more control over server parameter to fine tune your server for your requirement. So you can have more control and you can change many server parameter on the flexible server. The third feature which give you a maximum control for your database is the schedule maintenance. So this is one of the another feature which gives you freedom to choose when the maintenance should perform on your server. So right now we are providing two way to control the schedule maintenance. The first way you can control the schedule maintenance is leaving it to the system manage timing. So in the system manage timing, basically the maintenance will be performed as determined by the system, or If you want to have a more granular control, you can choose the custom time, and you can decide a 1 hour window where you want to have your schedule maintenance started. This gives you a lot of freedom, lot of control on your schedule maintenance, and you can schedule your maintenance when basically there is a very low workload and low users coming to your application. So this all this bundle and give you a maximum control for your database. The another thing which we have improved is building a resilient apps across availability zone. So with this flexible server offering for Azure MySQL, you have a choice to have a zone redundant HA. You can have your app choose the high available setup and have your server deployed and in AZ1, and with high availability it will keep a second copy, synchronous copy of your server in the second AZ. The another feature in this category is basically the fast failover with zero data loss. This is also achieved through HA. So with high availability setup, you will get a fast failover with basically zero data loss. So in planned and unplanned scenario, you can achieve a fast failover with basically near like zero data loss. The another most important things which we have received feedback from customer also is like collocating app and database in the same zone. So with Azure Flexible Server, in a coming weeks, you will have a ability to see which zone your database is deployed in, so that you can first choose your application tier to develop the application into the same availability zone. So for instance, you can deploy your Azure MySQL Flexible Server in AZ1, and you can also choose your Azure VM if your application is hosted on Azure VM to be in the same AZ as Azure MySQL. So this gives you a lot of resiliency in building the apps and gives you more performance. The another bucket where we have improved is the simplified developer experience. Here we have given the simplified end-to-end deployment, full compatibility with the community engine, and easy cost optimization feature like start, stop, and bustable server. So in the coming section, I will be discussing about the bustable servers which you can use to optimize cost, and there are feature like a start, stop, where you can stop your server for 7 days when you think that the workload is not at a peak hours, or you don't want to run your workload on the Azure MySQL for dev test scenarios where you tested the Azure MySQL and you want to stop for the next deployment to test it again. So we have improved there also to give the simplified developer experience to have a developer and test scenario for the Azure MySQL. So this is about the flexible server and the differentiating thing which we have launched on the flexible server. Let's go into the flexible server architecture. In the flexible server architecture, basically, as I was talking about, now you have availability to see which availability zone you are choosing for your flexible server. So as you can see in a diagram on the screen, you can see that MySQL flexible server is deployed in a Linux VM. And you can also choose and see the Linux VM compute tier through the Azure portal or the CLI. And we are using the premium storage and the backup storage also incorporated. And in the flexible server architecture, you can see that the flexible server is deployed in the availability zone. And you can see the availability zone in a coming few weeks, and as soon as you can see the availability zone, you can also deploy your Azure VM, AKS, and App Surface in the availability zone. That will give you a more performant workload. You can have develop and get more performance out of it, as you are keeping the application tier and the database in the same availability zone. So this will improve the performance manifold. So moving into the another aspect is basically the zone redundant HA architecture. So as we have discussed, to provide a resilient apps, this zone redundant HA architecture and flexible servers will allow you to have a standby MySQL server created in a different availability zone. So in case of unplanned and planned for failovers, you can get a fast failover to a standby server. So in this architecture, you can see on your screen that Azure MySQL Flexible Server is deployed in availability zone 1. And if you have a highly available setup, in that case, the standby replica or MySQL server will be created in availability zone 2, which will be where the logs and logs will be synchronously replicated to a MySQL, and you will get zero data loss when you are having unplanned and planned failover to the standby. So this architecture makes sure that the reads are synchronous. The read and the writes are synchronously replicated to Azure MySQL on a standby on availability zone 2. So this makes your application more resilient to failovers in unplanned and planned failovers. So let's deep down into our next section where you can see when to use single server versus flexible server. So this slide will help you to decide when you want to have a single server versus flexible server for your workload. So let's deep down in some of the nitty-gritties of single server versus flexible server. So as you see in a single server and flexible server, the database version on single server available is MySQL 5.7 and MySQL 8. As of now on flexible server, we have MySQL 5.7 and MySQL 8.0 will be coming in few months. And it is planned. Moving into the another feature is the high availability. If you see on a single server, you have a high availability through built-in HA, and that high availability is available in a single AZ. With flexible server, you can get the high availability in zone redundant HA. So basically, as we discussed, the zone redundant HA will keep a standby node in a different AZ, and with an automatic failover to that AZ in unplanned and planned for failovers. The third feature which we want to discuss is the schedule maintenance. In case of single server, the schedule maintenance is system managed, so the customer or the user doesn't have control over defining when the maintenance should go over your database server. But with a flexible server, you have system or custom schedule. So the user or the customer can decide when they want to have the server maintenance on the server. So if you want to have a 1 hour maintenance, you can decide which hour you want to have the maintenance on your flexible server. The another feature is start stop. The start stop feature is available on both single server and flexible server. Moving into the PITR point in time restore, the capability is also available on single server and flexible server. This capability allows you to restore your database according to your retention which you have configured on your server. The another feature which is network isolation. If you talk about network isolation on a single server is provided through private link, and the network isolation on the flexible server is provided through VNet integration. So on the flexible server, you have the freedom to choose the networking choice during the create experience also. So you can have your server deployed directly into a VNet and subnet decided by you. The another features which we want to discuss is the one feature is custom and managed key for encryption. It is available on the single server as of now, and on flexible server, the customer managed key for encryption is planned and will be coming in the coming months. Similarly, for the reserve instances, where you can take advantage of the reserve instances for a longer time. If you are looking to use Azure MySQL for a longer time, you can take reserve instances and utilize it for single server. But as of now on the flexible server, it is not available and it is planned for coming month. The same goes for cross-region read replica. And single server, you have cross-region read replica, but on flexible server, the cross-region read replica is planned and will be coming in the next few months. Moving into the uptime SLA. Uptime SLA on single server is basically 99.99%. But on a flexible server, the SLAs are still, as of now, is not available and will be coming in the coming month. So This shows you the complete side-by-side comparison of the key features in single server and flexible server, and which you can use. And basically, you can refer to this single slide to convert to see when you want to use a single server versus flexible server. So with said that, let's move into another section. And this section we will be talking about what matters most for getting max performance in Azure MySQL. So in this section, we will covering on many aspects. The first aspect is basically I will be covering on the physical proximity and accelerated networking. So here we'll be discussing about how physical proximity and accelerated networking helps your application to get the higher performance, and what we have seen when customer use customer consider physical proximity and use accelerated networking on their application side. The another in this section, another topic which we will be discussing about how basically connection efficiently matters the most when you are working with Azure MySQL or any cloud databases. In this, we'll be discussing about tools and tips for connecting efficiently, like connection pooling. The third topic which we'll be discussing about in this section is right sizing your workload. This is also important, as some of the key areas like IOPS, memory, CPU are dependent on the SKU which you have choose and can highly impact your performance. If you have a workload which is dependent on the CPU, memory, and IOPS. The next thing which we'll be discussing about query optimization. This is also very important, and we'll be looking for what to look for improving query performance when you are working with MySQL engine. The last thing which we'll be discussing about in this section is the server parameter optimization. Here basically we will be talking about two things in server parameter optimization. The first thing, on the Azure MySQL, when you are using Azure MySQL, what matters most to get the higher performance on and what you can change in the server parameter side to get the higher performance. The second thing which we'll be discussing is the parameters which you can use and fine tune when you are migrating to Azure MySQL. Many of the time we have seen that customer and the user doesn't change some of the parameter when they are migrating database to Azure MySQL, and these parameters can significantly help giving a faster load and to Azure MySQL, and can help you to get the migration done in matter of time. So let's deep down into this section, and in the first section we'll be discussing about the physical proximity. In physical proximity, basically what I mean by physical proximity when I call it out is, when you have a Azure MySQL, you know that you are deploying Azure MySQL in a region or in one availability zone. So for this example, I have taken an example of West US. So if you are deploying your Azure MySQL in West US, we highly recommend customer that to deploy their application or in this case the MySQL client in the same region and the same availability zone as Azure MySQL server. So as we have discussed already, this will help you and decrease the latency when you are connecting from your MySQL client to Azure MySQL, and this will give you a higher performance when you are connecting to your Azure MySQL. The another thing which you want to discuss on the same point is accelerated networking. Accelerated networking also plays a role in improving performance, and we always recommend customer to enable accelerated networking on our application VMs. And accelerated networkings help you to get a higher performance. So with accelerated enabled, I have some of the numbers on the slides. So with accelerated enabled, you can see when I have accelerated networking enabled, I see improvement in select one latency, and there is a manifold improvement in latency. The latency without accelerated networking was 1.18 milliseconds, and with accelerated networking enabled, the average latency went to 0.763 millisecond. So let's move into the different section, and the next section on basically dealing with connection efficiently in our agenda items. So with dealing with connection efficiently, I want to discuss about long-lived connection and the connection pooling. So when you are discussing with connecting efficiently, we want to discuss the first long-lived connection. In long-lived connection, what basically I want to discuss is when it comes to connection management and databases, The connection management is always, and forming a connection is always a resource intensive workload. And when you are forming a connection, you have to be mindful of different resources available. Every connection you made takes some of the resources on the database. So what I mean by long-lived connection is if your workload is creating many short connections, many short connections which are opening and closing in less than 10 milliseconds, then that workload will take a lot of memory utilization and the resource consumption on your database. And we always recommend customer to replace those short-lived connection with long-lived connection. And when you are replacing your short-lived connection with your long-lived connection, it comes with another point where you have to check that your long-lived connection are active and working. So these are the considerations which you have to make when you are seeing the burst of the connection on your workload, which can significantly use your Azure resources, or basically the database resources. So the recommendation on long-lived connection is avoid opening a new request for each connection, reuse existing connection, and make use of the timeout and close connection when it's done. The another point which I want to discuss when we are discussing about connection efficiently is connection pooling. You can utilize connection pooling to make use of long-lived connection, or basically to keep a pool of the connection, so that the connection pooling will help you. It will keep a pool of connection open, and whenever your application is requesting connection from database, it can reuse the already existing connection in your connection pool. So what helps in having a connection pooling is, first, every time you are not creating a new connection to your database, and the connection are utilized, the connection are already formed. So as soon as the application is connecting, the application has the connection ready in the connection pool, and application can use that connection. That decreases your latency and process overhead. So this gives you a more performance when you are having connection pooling. So to discuss more on connection pooling, as I described earlier, application requests connection from the pooler. So in this, if you have a connection pooling, application will go and request connection from the connection pool instead of going directly to a database every time, if in a case if you don't have a connection pooling. With connection pooling basically assigns one of the pre-established connection, as discussed earlier also. If you are going and having a connection pooling, you will not directly go to a database server. You will use the pre-existing connection available in the connection pooler. And the connection pooling and the connection pooler which you are using, or the logic which you are writing in your application, will basically automatically close and reassign connection if the connection is unused. And basically, with having a connection pooling gives your application many more inbound requests. So your application can make many more requests to the database server, and it basically helps you manage idle connections. So these are some of the benefits of connection pooling and connecting efficiently. With that, let's move into some of the component or the tools which you can use while you are utilizing connection pooling. With OSS databases and Azure MySQL and MariaDB, you can use ProxySQL. ProxySQL is another community tool, and which gives you out of the box connection pooling. You will get a high performance MySQL proxy. You can utilize this proxy with MySQL and MariaDB. And another big benefit of using ProxySQL is it will allow you to have an intelligent load balancing across different databases. So in case if with Azure database MySQL flexible server, you are having one source server and one replica server. And if you want to intelligently split the read and write workload on the source and the replica server, then you can use ProxySQL and define the query rules in the ProxySQL to split your write and the read without any change on your application side. So this gives you a lot of new features and reduces your overhead and writing read-write logic to split the read-write queries, and it gives you a higher performance. So if you have analytical queries which only expect the read queries, then you can redirect all your analytical queries and the read queries into a read replica using ProxySQL. So I have authored some of the blogs on basically this wonderful tool ProxySQL, And if you want to look, I have provided the link. The first link basically talks about how you can use proxy SQL for load balancing read write queries. The another blog talks about the proxy SQL, using proxy SQL as a sidecar. On the same, I have given an example in the third blog, which talks about using proxy SQL as a service on Azure Kubernetes services. And the fourth blog will tell you about some of the server parameter which you can use for connection pooling, improving and having the inbuilt retry logic. So these are the blogs which you can utilize and will help you set up a proxy SQL. Okay, moving into the next section, which is basically about right sizing for your workload, and one of the important section which you have to consider when you are moving to Azure MySQL Flexible Server. In this section, we will be discussing about how right sizing matters for your workload. So when you choose your Azure MySQL Flexible Server SKU, you have three choices: bustable, general purpose, and memory optimize. And all those three choices depends on intended use case. So if you have a workload which basically does not need full CPU continuously, then you can choose bustable SKU. If you have a business workload that require balanced compute and memory with scalable IO throughput, then you will be choosing you can consider and choose general purpose. Example includes servers for hosting web and mobile apps and other enterprise application. Memory optimize is basically for high performance databases workload that require in-memory performance for faster transition workload. So the use cases and the workload which include and fall in these categories are the workload which require processing real-time data and high performance transaction analytical queries. And this will be a best SKU if you want to have a higher performance and in-memory performance. So this choosing of the SKU based on your intended use case. On all the SKU, bustable, general purpose, memory optimize, you can see the VM series from the Azure portal. On the bustable, we are using B series. On general purpose, we are using DDS v4 series. In the memory optimize, we are using EDS v4 series. The vCore across bustable, general purpose, and memory optimize are again variable. On bustable, you have a choice to go from 1 and 2 vCores. On general purpose, you can choose from 2 to 64 vCores, and on memory optimize, you can choose from 2 to 64 vCores. When it comes from memory, the memory on the bustable is variable. On the general purpose, the memory goes from 4 gigabytes per vCore, and on memory optimized, the memory go to 8 gigabytes per vCore, with an exception on E64DS v4 SKU, where the memory is limited to 504 gigabytes. On the storage is pretty consistent. Storage is 5 gigabyte to 16 terabyte across all bustable, general purpose, and memory optimized SKU. The IOPS scaling is also consistent, which is 3 IOPS per gigabytes across all bustable, general purpose, and memory optimize. And there is the one thing which you have to consider on the IOPS scaling here: the maximum effective IOPS are defined by storage and compute. So as you see, you can get 3 IOPS per GB, but those effective IOPS are also limited based on the SKU. So for particular vCores, like 2 vCore, for example, 2 vCore on general purpose, DDS2v4 SKU, you can get 6 or 3200 IOPS. Then those IOPS are limited based on the compute. And on those side, you cannot go above 3200 even if you increase your storage. So those IOPS IOPS is a function of both compute and storage. And moving into expected latency, if you discuss about expected latency on different compute tier, on bustable the latency is variable. On general purpose, you will get single digit millisecond latency, and same for memory optimized single digit millisecond latencies. On the database backup retention period, you have a choice. On all the SKU, the choice is same, 1 to 35 days. So you can choose your data retention or the backup retention period for this from 1 to 35 days. Moving into another important factors is like IOPS, storage, CPU, and memory matters for when you are provisioning the storage, and when you are provisioning the storage, provisioning the SKU, and when you are basically running your workload on Azure MySQL or any other or on the MySQL community engine. So basically here you can see that most of the time when you are running a workload, your workload may be bound by the IOPS, and it is hitting the IOPS limit. In that case, as I told you, IOPS is a function of compute and storage. And if you are hitting the IOPS and you are on the GP2 vCore and you are utilizing the maximum IOPS from the compute, then you can consider moving to a 4-core machine to utilize the more IOPS, and or if you are not using the higher IOPS on the same SKU, then you can also consider increasing the storage to get the higher IOPS. So higher IOPS matters here. Similarly, for storage hitting upper limit, in this case, basically, if your server is hitting the storage limit, then in Azure MySQL, your server will be marked as read only, and the server can, in that case, only the read queries can go to the server. So basically, you have to also consider that for your workload that it is not hitting the storage limit. The another factor which you want to consider the metric is the CPU uses. If you are seeing in your workload the CPU usage is constantly hitting upper limits, then you can also consider increasing the number of cores from 2 core to 4 cores, and you can see the performance improvement if your workload is CPU bound. The another thing is the memory utilization. If the similar way, if your workload is memory bound, then you can choose increasing the core to align with the need of your workload, and you can keep track of these resources through Azure Monitor. And I have provided a link to how you can basically create alerts on these metrics to see when you are hitting the IOPS higher limit. You can get alerted on your alerted and see, okay, your workload is hitting the IOPS. You can also have like similar metrics and alerts on storage. So this gives you a freedom to have some settings and get the alerts based on when these limits are meeting. So let's move into another section where we'll be discussing about query optimization, and this also matters a lot when you are looking at getting at the higher performance from Azure MySQL Flexible Server. In this section, we'll be discussing about MySQL recommendation on writing queries and how can you efficiently write queries and how the queries are processed in MySQL. And the second thing is the slow query log, which is available on Azure MySQL Flexible Server, which you can utilize to see how your queries are performing. So let's go deep down into the first agenda for this section is MySQL recommendation. So before going deep into a MySQL recommendation, I want to talk about query execution basis in MySQL. So as you can see in a picture on your screen, before when you are sending a query to MySQL server, before parsing the query, if you are sending a select star, then before parsing the query, MySQL check whether the query exists in the query cache. If the query exists in query cache, the query results is returned, and the MySQL doesn't have to do other underlying processes like tokenize those query. If the query doesn't exist in the query cache, if there is no match, then the query optimization happens on the next step. The query optimization is basically a 3-step process where the parser first breaks the query into a different tokens, and the next step is basically query optimizer turns the query into execution plan, and the query execution after that take this execution plan, execute the queries. And after these three process has been done, the storage API is called to get the data. So the crux of this complete process is basically when you are writing the queries, you have to write the efficient queries and the queries which can be matched in the query cache, so that your result can be fetched pretty faster and the MySQL engine doesn't have to do much work in tokenizing and in optimizing those queries which you have written. So this is how the query basics works in MySQL. Moving into our next slide, basically that was a query basics, how it happens in MySQL. How can you basically optimize data access? How can you say like you are not using using the MySQL engine in a way where it is optimized. It's not optimized. So the first point which I want to discuss is that you can fetch only the things you need. What I basically mean is, if you see on the screen, the first query is a simple query. There is no change. It's an adjoin between two tables and fetching the row where the title of the film was Academy Dinosaur. So in this query, if you see, all the rows from actor and the film actor table has been fetched. But if in reality, if we need only the rows from the actor table, then this query is not optimized. It's getting more data than what I expected. So the one of the improved query which can be is to fetch on the rows which is needed for me. So that's what you can do. And in the second query, if you see, I am only fetching only the things which I need, and I have scoped the select query to only the actor tables. The second thing is, when you are optimizing data access, is you have to think about, is your MySQL examining too much? What I mean is, like, you have written your query, is MySQL looking at many rows what you expected? If I'm saying select a star from actor table where my row ID is equal to 1. So from my understanding, I only expect that MySQL will optimize and only analyze only one row. But some of the time when we are writing query, we don't look at some of the indexes and some of the nitty-gritty in the MySQL. So we also want to discuss whether these things we can improve. So one of the tool which we have on the MySQL side is the explain command. So you can basically use the explain command to obtain a query execution plan. So whenever you are running a query and you are seeing that the query is taking a lot performance, you can basically lot time to fetch the result. You can use the explain command. So I have given an example of the explain command for the two queries. If you see, I am in the first query on your left side, where I am using select a star from film actor table where film ID is equal to 1. And when I'm running the same query with explain command, you can see that the explain is only looking at the 10 rows, and this is returning pretty fast. But what I will do to explain it, I will remove the foreign key and foreign key basically from the table, and indexes from the table, and I will see how it happens. So when I'm running the same query after removing the indexes on the table, you can see that the rows analyzed by the second query, the same query without the indexes, is 5073, and that is a lot from the 10 result analyzed by the same query without indexes. So here what I'm trying to explain is, there are some of the concepts which are more important and you should understand when you are writing a query, performant query. And here I am trying to explain the indexes. So if you see in my first query, when I'm running the index, there was no indexes, and in the second query, when the rows are analyzed and the rows analyzed were 10, I have indexes on my table. So what is basically indexes? An index is basically make your search query faster. And if you don't have an indexes on your server, on your table on a particular server, if you don't have an indexed table, it will basically is an unordered collection of rows. So if there is no indexes, MySQL engine will not know what rows it has to find out quickly. And in that case, as you see in my previous example, it was looking at all the 5,000 rows to get me the rows, the intended rows which I have. So basically, if you have indexes, indexes will make your search query run faster, and your data will be ordered in that case. In MySQL, you can also use full text indexes to optimize searching against large amount of data. And indexes like unique index help avoid duplicates also. So you can have unique index to avoid duplicate also. So these are some of the basic principles of improving the query performance on MySQL. Moving into a second step on how to troubleshoot whether your queries are performing slow. You can also use slow query log basically to identify the performance bottleneck while you are troubleshooting. You can enable slow query log on your server and see which queries are performing slow on your server, and we always recommend turning on slow query logs during the troubleshooting analysis to see which queries are performing slow, and because turning a slow query log is also has some performance impact on your server. So we recommend to only enable slow query log to analyze and troubleshoot, and then disable it. You can get more details about slow query logs, and I have shared a link for the slow query logs, and you can get more details on that link. Going into the another agenda item, and where we have the server parameter tunings. In this section, basically we will be discussing about two aspects of server parameters. The first aspect is how can you tune the server parameter and what you have to consider to get the higher performance. And second aspect is what server parameter you can use and you fine tune to get the higher data ingestion when you are migrating. So let's move into a first point where we'll be discussing tuning some of the server parameter for performance. Some of the recommendation which we have for the server parameter, the first one is InnoDB buffer pool size. Our recommendation to set the value of the InnoDB buffer pool size is always like set the value of this parameter to 60 or 70% of your total memory size. And this parameter basically tells you what is the size in bytes of the buffer pool, the memory area where basically the InnoDB caches the table and indexed data. So the higher the value, the more the InnoDB will cache more table index, and your query result will be faster. The another parameter on the same lines, InnoDB file per table. This is another parameter which basically takes care of how the InnoDB stores the data and indexes for each newly created tables. So in MySQL, all the newly created table is and all the data indexes basically are stored in .ibd files. And this parameter InnoDB file per table will take care whether you want to store those IBD files into the IBD files or the system table space. So if you have this InnoDB file per table variable set to 1, that all the tables will not be created in the system table space. So the recommendation here for the server parameter is whenever you have greater than 500 tables, then set the server parameter to 0. Why the recommendation is coming here when you have like greater than 500 table is when there will be a server restart on Azure MySQL flexible server, or when you are restarting or increasing the compute, that if you have more than 500 tables, for example, say 1,000 to 2,000 tables, then it will take a lot of time scanning if you have this InnoDB file per table variable on. So our recommendation always is that if you have less than 500 tables, then set this parameter to 1 so that all the table, instead of going to the system table space, goes to the InnoDB file per table. The another advantage is when you delete any table, then if you have InnoDB file per table on and you are deleting that table, you can reclaim those space from the IBD files. So this is also one of the advantage of InnoDB file per table parameter. The another two parameter is query cache type and query cache size. So these parameters in both take care of the query cache type and the amount of memory basically allocated for caching query results. So we recommend to set both those parameters to 0, and this will entirely disable the query cache and improve the performance. All the other server parameters which we have in Azure MySQL, we have configured with the default and recommended values, and we have make sure to fine tune all other server parameters. So these are some of the most important parameters which we have seen, and we will be maintaining the list of other server parameters which you can fine tune on our public documentation, which I will be sharing the links in the recommended docs later. So moving into the second agenda item is what are the migration choices available if I want to migrate to Azure MySQL flexible server, and what are the server parameters which I can fine tune. So as of now, you have two choices if you want to migrate to Azure MySQL flexible server. The first choice is using MySQL dump and restore. The dump and restore, MySQL dump and restore basically dump and load database into Azure MySQL. And if you are using MySQL dump and restore, the downtime will be there for the period of migration. So you have to first take a dump of the data of a MySQL database from the source, and then you have to restore that database into Azure MySQL flexible server. So during the time of this operation, when you are performing this operation of MySQL dump and restore, the downtime will be there for your application. We have some of the recommendation on the pricing tier and server parameter for migration, and I have provided a link down there. So you can refer the two links for MySQL dump and restore and the recommendation for pricing tier and server parameter for migration. And I will be also going for this recommendation in a while after this presentation. The another tool which you can use to migrate to flexible server is MyDumper and MyLoader. What is the main difference between MyDumper and MyLoader and MySQL dump and restore? The main difference between these two tools is basically MyDumper and MyLoader is a multi-threaded data export and import tool, which makes your data export and import pretty fast, so that you have lesser downtime compared to MySQL dump and restore. But again, one more point you have to note here, though MyDumper and MyLoader will be pretty fast from MySQL dump and restore, but still the downtime will be there for the migration period. The migration period will be cut down to short, so we recommend to use MyDumper and MyLoader to migrate to Azure database for MySQL flexible server. And we have some of the parameter recommendation for MyDumper specific, and I have provided a link to one of our wonderful blog where we have documented the process and what parameter you can use on your MyDumper and MyLoader side to have a faster data load and data import from MySQL to Azure MySQL flexible server. And there are some of the recommendation also, and the link is provided in MyDumper and MyLoader. Moving into the server parameter which I was talking previously, which you can fine tune for migration. There are some of the server parameter which you can fine tune. The first server parameter is basically max allowed packet. This server parameter prevent overflow issue due to long rows. So we always recommend to set this max allowed packet to 1 GB. The another parameter is slow query log. As discussed earlier also, we recommend to only use slow query logs when you are troubleshooting, and we recommend to set the slow query log to off during migration, so that it will not impact the data load into Azure database MySQL flexible server. The another parameter is InnoDB buffer pool size. Buffer pool size basically can only be increased by scaling up the compute. So we recommend when you are using Azure MySQL and you are performing the migration, we always recommend to use memory optimized 32-week or the higher SKU, so to migrate pretty fastly, so that the data load can be faster. The another aspect, and basically it's not a server parameter, but the another aspect is you can increase the IOPS also. What IOPS will do is make the data load faster on the storage side, and you can consider scaling up the storage to increase the IOPS. Or basically, if you are on the memory optimized SKU, you will get 20,000 IOPS. You only have to increase the storage to get the higher IOPS. One thing to note on this recommendation is you should increase the IOPS, but increasing the IOPS, you have to increase the storage. And on Azure MySQL flexible server, as of now, there is no way to scale the storage down. So if you are scaling the storage to get the higher IOPS, please make a note that storage cannot be scaled down. In the next section, let's move into a more interesting section, which is basically a MySQL demo. In this demo, I will be showing you what basically I'm running against Azure MySQL, AWS RDS, and MySQL on-prem. So here you will be showing the performance with write SKU plus IOPS and the performance comparison between all these three offerings, basically Azure Flexible Server, MySQL on-prem, and AWS RDS. So let's go towards the demo. Let's first show you guys what I'm running. So basically, if you see, I'm running this test 10 hours and 20 hours running a long test on against Azure MySQL Flexible Server. And as you can see on some of the values written by this benchmark is, you can see the performance written by the workload. For some of the details, I'm running sysbench read write workload against Azure Flexible Server, and this workload in all the identical setups are running against AWS RDS and Azure and MySQL on-prem. And I will be showing you a complete performance comparison of a 10 hours run. But as you see the performance on some of the tests which are running live now, you can see that you are getting the higher QPS. This is Azure MySQL, and you are getting a QPS of 35,000 with a latency, 99% latency of 200 or something, around 200. So let's go. These are the tests which I am running live right now. Let's go and see the performance comparison across all these servers with a live test. So as you can see in this Grafana dashboard, I'm running this test. This test is run, the granularity is last 15 minutes. I'm looking at the last 15 minutes. And if you see, my selected server is my demo server.mysql.database.azure.com. This is basically my flexible server, and you can get this detail. You can see the flexible server here, which I'm using. And the flexible server, you can see the performance on the flexible server. I am getting average of 28,000 QPS with 29,000.59 max QPS, which I have got on Azure MySQL. And if you go into the AWS RDS, you can see the AWS RDS comparison on the QPS. On the QPS on RDS, it's comparable. It's giving you 28,091 QPS. And moving into the on-prem, the server or MySQL which I'm using, you are getting a QPS of around 28.45 thousand QPS. So the main thing to note that the performance here is comparable across AWS RDS, Azure MySQL, and MySQL on-prem. The other thing you want to note is, if you are comparing the performance and the throughput and the QPS on different offering, you can see that the performance is basically zigzag when you look at on-prem and AWS RDS performance. But if you look at the performance on Azure MySQL, you can see that the performance on Azure MySQL is pretty much straight line, and compared to AWS RDS and MySQL on-prem. So this is the performance basically benchmarking which we are running, and I've showed you the live test on basically different SKU. The SKU which I have used here is a 16 core general purpose SKU. And I have also included a slide for my 19 hours run. I have performed one more 19 hours run where I have performed the test across RDS, Azure MySQL, and MySQL on-prem, and you can refer to a slide for the Grafana dashboard which shows the testing results for that also. So moving forward, I have also shared some of the MySQL resources. You can go look at the flexible server docs. The link is presented here. You can also look at the flexible server launch blog. And if you have any question and if you want to reach out to me, you can reach out from our alias ask@azure-db4mysql@service.microsoft.com. And please let me know if you have any questions and any other question on performance improvement, or if you have any question related to flexible server. Thank you everyone for attending this presentation.